So our last chapter, this is really chapter 10, but we are going to go back, like I said, and look at a little bit from 2.8. Our goals today, to review distance and midpoint formulas, and then we're going to shift to circles. Now, as we go through the 4 different conic sections, we are going to focus first on what does it look like if it's centered at the origin, and then what does it look like if we translate it, shift it off of that. Okay? For circles, because it's our most basic conic, we're going to do all of that today. But in the other 3 shapes, we will split it up. We'll have one day just focused at the origin before we shift it somewhere else. Okay? So we're looking at, can we write an equation for a circle if I give you criteria like what its center is, what its radius is? Second thing is, can we graph it if I give you the equation, but I don't tell you anything else about it? Can you pick out what is the center and the radius from the equation? Okay. All right, so distance. You guys learned distance and midpoint formula probably back in Algebra 1. We're just doing a quick review of it here. We have a line segment with 2 endpoints. One is labeled x1, y1, the other one's labeled x2, y2. It does not matter which is which. Okay? In our distance formula, we have d equals the square root of a whole bunch of stuff. Underneath that square root symbol, we have the quantity x2 minus x1 squared and the quantity y2 minus y1 squared. We add them together before we square root the whole thing. Take a minute, double check that you've written that one down correctly. All right, so our first example, it says find the distance between the points -1, 4 and 3, -2. I typically write out my basic formula. I know there's a big square root. I know I have 2 quantities that are getting squared and then added together. And I know that inside those quantities I have what operation sign? Yeah, we are subtracting. Okay? So I will typically do all of that before I even deal with any numbers. Because students often make mistakes here with negative coordinates being plugged in next to a minus sign. Okay? All right, in the first ordered pair, we need to put our x's. Which coordinates are my x's? The -1 and the 3. All right? So I can put in here 3 minus -1. I can put in here -1 minus 3. One way gets me a negative answer. One way gets me a positive answer. But when I go and square it, it's going to come out the same. Okay? That's why I said it doesn't matter which is called 0.2, which is called 0.1. All right. So if we put in 3 minus a -1, what would I use in the second one? Okay? My x's go in the first one. My y's go in the second one, right? Okay. Then we need to simplify. 3 minus a -1 is 4, and 4 squared is 16. All right. In the second grouping, I have a -2 minus 4, which gets me -6 squared, 36. 16 plus 36 is 52. So if I wanted an exact length, that would be it. It's the square root of 52. That's exact. Okay? If you were going to do something with that, maybe you had to draw it on a graph or something, all right, you need to know, well, what is the square root of 52? It's a little more than what number? A little more than 7, right? Square root of 49 would be 7. So it's going to be 7 point something. All right, grab your calculators. Give me a couple decimals there. Square root of 52. All right, seeing 7.21. Okay. We good with that? All right, second formula is our midpoint formula. It says consider a line segment that has endpoints x1, y1, and x2, y2. The coordinates for the segment's midpoint are given here. Notice you are taking the two x values this time and adding them together and dividing by 2. And then you're doing the same with the y coordinates. If you take two numbers and add them together and divide by 2, you have found its average, right? So think of midpoint as the average of your x's and the average of your y's. Go ahead and take a second and write that equation down. So next we want to find the midpoint of that same set of points, -1, 4 and 3, -2. All right, so midpoint, remember we are adding things and dividing by 2. Okay, what numbers are we adding in the first one? Okay, again, those x's, so -1 and 3. And then in the second set, we put our y's, the 4 and the -2. Okay, so in distance, you're subtracting x's and subtracting y's. In midpoint, you're adding them. In distance, you square it. In midpoint, you divide by 2. So, slight differences. What do we get here? -1 plus 2 is, sorry, -1 plus 3 is 2. 2 divided by 2 is 1. And in the other one, 4 plus -2 divided by 2, 1. Okay, so the point 1, 1 would be your midpoint of that segment. Questions on either of those two formulas? Okay. We're going to pause the video at the top of the next page. You have another set of ordered pairs. I want you to find the distance and the midpoint for that segment. All right, let's check. Distance. All right, what numbers did you put in the first set of parentheses? -8 and a 1. Okay, and in the second set, -4 and a -6. All right, so -8 minus 1 would be -9. Squared would be 81. And then in the other set, we have -4 plus 6, which would be 2. Squared is 4. So exact answer, square root of 85. Approximate answer, 9.22. All right, we good with that? All right, midpoint. We need to take our x's and add them together, divide by 2. Do the same thing with our y's. We're going to add them together and divide by 2. So for my x's, what do we end up with? And I'm okay with you writing it as -7/2. I'm okay with you writing it as -3.5. If it doesn't come out to be an ending decimal, though, you're better off leaving it as a fraction. Okay, it's more exact. And then our y values, we have -10 divided by 2 or -5. Agree? All right. We good to move on? Distance, midpoint? Okay. All right, so our first conic section is the circle. What do we know about circles? They what? Does the picture look familiar? Yes? The term radius sound familiar? Radius is the distance from center point to the edge of your circle. Yes? So a circle by definition is the set of all points in a plane that are equidistant or the same distance from a fixed point called the center. Okay? So the points that make up that outer circle are all the same distance from the center, and that distance would be considered the radius of the circle. Okay? So we have your first formula that you need to start memorizing. All right? The circle formula looks like this. We have x minus h quantity squared plus y minus k quantity squared equaling r squared. The h and the k are your center point, okay, the coordinates for your center. The radius is the r in this equation, okay? Now, this is a basic formula that works no matter where the center is. But what would it look like if it was centered at the origin? What changes? Right. We have x squared plus y squared equals r squared because h and k is just 0, 0. Right? So those little pieces drop out. But again, if you memorize the one I have in the box, the big long formula, it will always work for all circles. Right? And you could just take the hk out if it's centered at the origin. All right, first example. It says find an equation for a circle that has a center at 3, 4 and a radius of 2, and then we're going to graph it. Okay, so if the center is 3, 4, and that is hk, that means h has to be 3 and k has to be 4. And they're telling me the radius is 2, which is my r value in my equation. So I have all the numbers, I just have to dump them in the right spot. Okay? All right, our basic setup, we have x minus the h value, right? The x coordinate of your center. So x minus 3, that quantity squared. And then our next quantity getting squared is y minus k. K in this case is a positive 4. And then it's equal to r squared. That is one thing that a lot of students forget, to square that r. All the quantities here are getting squared, right? X minus h is getting squared, y minus k is getting squared, r is getting squared. So 2 squared would be 4. So that's the equation that fits that criteria. If you were going to graph it, we are told the center was 3, 4. So we're going to put a dot at 3, 4. And then if the radius is 2, to draw our circle, we're just going to go 2 in all 4 of our main directions. Okay? So 2 to the right, put a dot. 2 up, put a dot. 2 to the left, put a dot. And 2 below, put a dot. So you're just going out 2 spaces in each direction from that center point. All right? And then just draw the best circle you can. Okay? All right, it says find and graph an equation of the circle that has a center at 0, -6 and a radius of 10. Now, because of the size of this one, for our graph, we are going to go by 2's. All right, I'm going to pause the recording. I want you guys at your tables to try this one, check with each other, and then we'll check back as a group. Okay, so remember our formula says x minus something squared plus y minus something squared equals r squared. Okay, we're told the radius is 10. So 10 squared is going to give us 100 on the end. Okay, what are we putting in for h and k? All right, 0 goes in there with the x, -6 with the y. X minus 0 really simplifies down to just x, right? So I would not mark it wrong if you left x minus 0 quantity squared, but in your textbook, you'd never see it written that way, all right? You're just going to see an x squared. The y minus -6, we would simplify to be y plus 6 quantity squared. And there's your equation. We good with that? All right. I said to go by 2's for our graph. So 0, -6 is actually only going to be down 3. Okay. And then if we're doing a radius of 10, we're really counting how many tick marks? 5. Yep. All right. And then draw your circle in. Okay. All right. Example 3. Find the center and radius of the circle and then graph it based on your equation. So we have x minus 5 quantity squared plus y plus 4 quantity squared equaling 9. We need to figure out the center and the radius. Let's start with radius. What would radius be? 3, because r squared is 9, so r would have to be a 3. Center, most common mistake are the signs. Okay? In your basic circle formula, it's x minus something and y minus something, right? So in this first piece, x minus 5 quantity squared means that h is 5, right? X minus h. H is 5. But what about in the y section? Yeah, you have to think about that as y minus a -4. So our k value is -4. All right, let's plot that point. We're going to do a radius of 3. So we're going to go 3 spaces in each direction. And draw it in. Now there's one extra question that's being asked here. It says use your graph to determine the domain and range of the relation. So the points on my circle, right? We have a maximum and a minimum for x, and we have a maximum and minimum for y. Our domain represents our x values. Range represents our y values. So just going in the horizontal or x direction. Okay? Our smallest x value is right there. Right? We have an x value of 2. And our biggest x value is an 8. So all of the x's are somewhere between 2 and 8. Does that make sense? So our domain would be all values including the 2 and the 8. Okay. Now, could we have figured that out without seeing a picture of it? Well, we said domain was x's, right? So let's start with our 5 here, our center, our x coordinate of our center. And to draw the circle, we had to move left 3 and right 3 from there. Yes? So if we take 5 and subtract 3, we get our 2. And if we take 5 and add 3, we get our 8. Okay? So we could figure it out without actually seeing it if you didn't have to have a graph drawn. Okay, how about for our y values? The highest y here is -1, and our lowest y value is -7. So remember, we start smallest up to largest. So our range is going from -1 up to, from -7 up to -1. And again, we could have found that by taking this -4 and subtracting 3 and then adding 3, right, to get our 2 different values. Okay, we have one more to look at. I'm going to pause the video and let you guys try this one on your own first, and then we'll come back and check. So center for our last one here is what values? -3, +1, right? And then radius would be a 7. So let's graph that. -3, 1 be over here. And we're going up 7. We're going down 7. Left 7. and right 7. All right, pretend that's a circle. Okay, last question. Use the graph to determine the domain and range. So again, we can base it off of our picture. We can base it off of our coordinates. If we are at -3 for a center for x, we have to subtract 7 and add 7. Yes? So from this point, -3, -3, wherever it was, go that way 7, go that way 7. Okay? So what do we get for domain? -10, 4? I don't know what happened to my board all of a sudden. It's still off, but we'll get there. All right, range. I'll try it over here. Oh, doesn't like me anymore. Hang on. All right, let's try this again. So we said our domain went from -10 to 4. Our range is going to go from what? -6 to +8? Yes? Okay. Questions on circles? Are we at a 3 or 4 at least? At least a 3? We got it? Okay. I said before, and I'm going to say it again. Every time we add a new shape, you better know the one before it, right? And then start comparing. How is this like what I already know? How is this different? What are the characteristics? So for a circle, our key features are where's the center and what's the radius, right? That's what we need to know to create a circle. Okay. Tomorrow we get to start ellipses. All right.